All right, we had a few slides to go through. Then we have the microscope lab. I want to present that. Give you some lab time today. All right, so before the break, we kind of talked about the different tonicities. Let's review the one where it was a hypotonic condition. So that kind of relates to these terms here. In that one, it was the cell would swell because the solution it's immersed in was hypotonic, say 5, and then the cell was higher. You got this net fluid entering the cell, and it caused the cell to swell to the point where maybe it's about to burst. Okay, and as the cell swells in a hypotonic solution that it's immersed in, ready to burst, let's understand that the ability to draw water into a cell, we call that osmotic pressure, this condition here. The cell's ability to take on fluids is osmotic pressure. I always think of it as this is a pressure. It's a suck fluid into you pressure. Okay. Ability to draw water into a cell or something else. Ability to draw water into anything. It could be a blood vessel. You know, or anything. You draw water into yourself, that's osmotic pressure. Now the result of that is hydrostatic pressure. Hydrostatic pressure is the back pressure exerted by water against the cell membrane in this example. As water diffuses into a cell, due to osmotic pressure, the point is reached where water in the cell is pushing out. And that prevents more water from diffusing in. So as pressure builds, because you're filling it with fluid, at some point, the back pressure of the water in here that's flowing inside it's starting to push back out on all sides, this back pressure. And at some point, the water trying to diffuse in won't, because it's counteracted by this back pressure or hydrostatic pressure. It's the pressure of the cell about to burst due to the water pushing against the cell membrane. So hydrostatic pressure. I'll paraphrase that. I'll say it's the back pressure. I'll say that. It's the back pressure. Of water in the cell pushing out against the cell membrane, pushing out. Pushing out on the cell membrane. Think of it as this. Hydrostatic pressure opposes osmotic pressure. It's working against it. Opposes osmotic pressure. So the two kind of go hand in hand, right? Because osmotic pressure, you're filling it up, but then as you fill, the back pressure is building up. And at some point, they cancel each other out. So that's what I show here. The hydrostatic pressure is building up inside the cell. Let's say you have a shrunk cell, but then all of a sudden you immerse it in a hypotonic condition where the cell swells. In this condition here, it would be difficult for water to diffuse in because there's so much pressure built up inside the cell already. Okay, that's the point of understanding this concept and this concept. That's the basic idea. Any questions on osmotic versus hydrostatic? It's just a for example, in physiology, if you have high blood pressure, why would the doctor recommend a low sodium diet? Oh, well, decreases that. And your vasculature won't hold on to as much fluids, okay? Do you ever notice how thirsty you get after eating pizza, all that salt? Because like you're increasing all the salt there, and you want to drink more water to dilute it out. Here's what you're going to do in lab on Wednesday. You'll just kind of put some kind of a solution in there. It could be a glucose starch, salt solution, and you'll weigh it, okay? Get a little pre-weigh, and then you're going to incubate it for like an hour, and then get a post-weigh. And I'll break you into groups. I usually have you group yourselves, and where we're at now, the numbers usually turns out 3 to 4 per group. Most groups should have 4. I'll let you self-group on Wednesday because we only have enough resources to set up 10 little boxes. And you'll get to test one of these solutions. And we'll get some class data. That'll be Wednesday, just to give you a preview. And today is microscopes. And today we have enough scopes so you can work in pairs today. So let's finish up these slides. I think there's a YouTube figure that I wanted to present. I think it was on a previous slide. Let me show you this one here. Okay, sorry, last thing. Whew. Okay, this one, we call it the U-tube example because the U-shaped tube has a partition in it that allows for the diffusion of the water and the red solute that's in there. Over time, it's less concentrated over here. If the solute and the fluid are allowed to pass, you have equal volume, equal concentration. Does that make sense? Due to osmosis and diffusion of the solute. The other condition is if the permeable membrane in the middle allows water to pass through, but not the solute. The little pores in the permeable membrane are too small. So that'll allow the osmosis of water, but not the diffusion of the solute. And so over time, you have unequal volume, but equal concentration. So it does depend if the molecule in your dialysis tubing can move through the bag or not. And that's something you're actually going to test for. And it's all explained in the procedure. Okay, and that's Wednesday's lab. I always like to do the lecture, not the same day of, but like days before the lab, so you have time to think about osmosis. Today's lab is microscopy, so let's shift gears in the lab. What I'm going to do is show you what to expect, and a few copies left here. Since I said you could work in pairs, once you kind of sort yourselves out, I don't pair you up. I always let students figure that out. I don't like to micromanage my labs, but if you need help finding a partner, I can assist. But I don't want to have to do it for everybody. Usually you guys can do it yourself. It's pretty standard. I have a pretty basic picture of a microscope. And the goal of this lab is, can you use a microscope? Just to put it, I can't put it any more simply than that. And for the first lab, I always like to make it a very relaxed learning environment. So I'm not going to collect this lab until next week, Monday. I don't want you to feel like you have to finish it today. Sometimes I do. Sometimes I'm like, okay, do today, turn it in today. But this one, I'm not going to collect it until a week from today. That's, I believe that's February 3rd. Yes. Microscope lab. do Monday, Feb 3. Now the reason why I want to allow another date is because I do want you to use the scope. And we have time today. But on Wednesday, for that 1 hour incubation, you don't have much to do. So maybe if you didn't finish it today, you could finish it Wednesday. On this Friday, let's say you wanted to go to open lab this Friday. You can do this in open lab. I mean, in the room next door where the open lab is, they have scopes, and you can ask Jeff for the slides, and he'll get them for you if they don't have them over there already. Okay, so it could be done in open lab. So that's why I'll collect it Monday. So you can do it today, you can do it Wednesday, you can do it Friday, and then you can just turn it in today if you want, or you can just turn it in on Monday. Okay. Oh, the signs are right there.
11:30.